Hey y'all, today we're going to be going over AI in Unreal. So in a third-person blueprint project, let's get started. So let's just create a new folder here and just call it AI. And all of our AI stuff will go in here. Now, AI is kind of a confusing topic in a lot of ways, a little bit unnecessarily confusing in my opinion. I'll get into that a little bit more. So there's like three things that we need to get started. Firstly, we're going to need the character. Secondly, we're going to need the behavior tree. Thirdly, we're going to need an AI controller. If you go to this drop down here in the all classes and then just search for AI controller, it'll show up here. And then lastly, the Blackboard. And I'll just call this one enemy underscore Blackboard. The character that we added will be BP underscore enemy. And then the behavior tree will be BT underscore enemy. And then lastly, AI controller underscore enemy. So just a brief explanation of what these are. As we get into it, it'll make a little bit more sense. The character that we added is going to be like the actual unit itself that we see in the game. The behavior tree is kind of like what the AI is thinking, and it's gonna kind of be what makes decisions for the character. The AI controller can do some other fancy stuff like sight and hearing. And then the Blackboard is kind of where the behavior tree variables are stored. To be honest, I don't know why this is necessary as like a separate thing. So the first thing that we're going to do is go into our character. And then if we search in here, AI controller, you can see this shows up with the AI controller class and it defaults to just AI controller. This is just kind of within the engine. The one that we added is AI controller underscore enemy. Let's add that. And this will just kind of be tied to the character. So this will run as soon as the character runs, as long as you have your other settings at the default, because there are other settings related to that. So now let's go into the AI controller here. And this might show up. We can just click open full blueprint editor there. Let's get rid of that. Okay, so on begin play here, so right when the AI controller starts, we're going to run behavior tree. And basically the behavior tree won't actually run until we tell the AI controller to run it. And this will just be a list here of like all of the behavior trees that you have in your project. In our case, we only have one. So let's just select that. And now the behavior tree will run as soon as the AI controller runs. And for purposes of right now, that's really the main purpose of the AI controller, is to just make sure that the behavior tree is actually running, because the AI controller is linked to the character itself. So it's just sort of a this happens, then this happens sort of deal. All right, so now we can actually get to the more interesting part, which is the behavior tree. And by default, there's nothing here other than the root. And this menu probably looks unfamiliar. So this isn't really a blueprint per se. You can see all this other stuff here, but just like a normal blueprint, you can scroll up and down and use the right mouse button and drag to move around. But the way nodes work in this behavior tree is a lot different from how they work in a blueprint. If you drag off of this downward, then you're going to see three options: a selector, a sequence, and a simple parallel. For now, I'm just going to select sequence. And then if we drag off of this now, now we have another section called tasks. Before we just had this composite section when we dragged off of the root, but because we're dragging off of a composite node, we now have this tasks section, and there's a bunch of stuff here actually, some of which are pretty self-explanatory, like wait, which is kind of like a delay, and play sound, which will play a sound, and then move to, which will just move the character to a certain location. That being said, it does work differently from set actor location because it won't be instant. I'll get more into that. So you see how it says move to invalid? It probably won't say that for you. If for whatever reason it does, go ahead and click on the root node, and then in this Blackboard asset section, click the drop down and then select the Blackboard. It should default to this if you only have one Blackboard in your project. And now this says self actor. So this is just connected to the behavior tree. Now we're actually not limited to this selection of tasks. We can create our own task by just going up here. And then if you click it, then the content browser will show up because tasks are actually their own blueprint. So I'm just going to create a new folder here and call it tasks. And I'm probably going to name this bttask underscore get random location. Generate random location also wouldn't be a bad name. And now we have a completely empty blueprint graph. And notice how we're missing our construction script and our viewport. And that's just because the blueprint type bttask blueprint base isn't an actor. So actors have a construction script and a viewport, but bttask blueprint bases don't. So let's just right click and then search for event receive. And there's a couple options here. The one we want is receive execute AI. So this is just whenever the behavior tree hits this task. So let's take a moment to talk about how the behavior tree operates. So right when the behavior tree is started, it's going to execute whatever's right below the root first. This is basically going to fire off as soon as this event, as soon as this task is hit in the behavior tree. So if we compile this and then drag off from here, and then just go to this dropdown, you can see we have a new task here, and this is actually the one that we created. Let's just click that. So basically, when the behavior tree is started, it's gonna go down just like an execution of a blueprint. But the way a sequence works is that it's going to run what's on the left, and then it's gonna run what's on the right. More on this later. But when it hits this, then event receive execute AI will fire off. So the owner controller here will be the AI controller because the behavior tree is going to identify the target here. And then the controlled pawn will be our character. But it's important to note that these are just pawn object references and AI controller object references. It's not going to be this specific AI controller and this specific BP underscore enemy until you cast it. So like I said, we want to generate a random location, and we can do that using a get random reachable point in radius. That's a rather long function name, actually. I think this one might be new in 5.1. Let's just go with this one. So this is the primary node that we're going to use for this task, right? It's going to generate a random location for us. And it's asking for an origin and a radius. The origin is like where it will start from. And then the radius is how far from the origin that it's going to search around. So we can't just use 0, 0, 0 as the origin point. The AI character won't necessarily be located at 0, 0, 0. So as the origin, we want where the unit is located, right? And we can just do that using a get actor location. So this will be where the unit is located. And we want to search, let's say 1500 centimeters around. If we just use some random point, then that could be very far off. Now, one way we actually could accomplish the task of moving to a certain location is by using, actually it's in the owner controller, simple move to location. And then we can set our random location as the goal. This will actually work, and I'll actually show that. If I compile, and then go to the behavior tree, we don't need this anymore. Let's go to the character, and then just add like many simple, and then move it down here. And then I'm also going to rotate this, because the idea is that where this arrow is pointing is like the forward direction. And then we can also set the animation blueprint to this one, which is like designed for this. Compile that and just close that. And then we can drag our character into the world. If we play here, nothing is actually going to happen. And there's one main reason why that is. It's because we don't have a nav mesh bounds volume, which will basically just tell the AI that, hey, you can move around in this area. How we add one is in the place actors panel, nav mesh, and you see nav mesh bounds volume. We can just drag that in. And then I'm going to scale it up. And again, like this cube decides where the AI can walk around. So it's not going to go beyond this, right? So now I'm going to hit play again. And now you can see that the character is moving a little bit. It's actually going to stop, and I'll go over why that is in a minute. Now, something that is kind of weird in 5.1 is that now we actually can't see our character. I think this has to do with like world partition, but if we go search for our character here, you'll see like it says unloaded and we can't actually see it. We can go ahead and right click and then pin. Now we can see it again. There's actually two issues with what just occurred there. First of all, you might have noticed that the animation was not working. And then second of all, it was pretty obvious that the character only moved once and then just kind of deactivated after that. I'll go over the animation first. So in the character here where it says animation class, if we browse to that and then open it up, there's a bunch of stuff here. I'm not going to go over all of this right now, but what's causing our problem is this right here. If we get rid of this condition, and then get rid of it as well, and then just connect that, it should play the animation now. One other thing, actually, the nav mesh bounds volume also kind of unloaded there. So we can just go over to this and then pin it. And I'm just going to hit play. So you see now it's actually playing the animation. So now the second problem, that the unit just deactivates. So in our behavior tree, in this task, we aren't ever actually finishing this task because we haven't told it to finish. So like normally in a blueprint, like when there's no more execution outputs, it just sort of stops running and there's no issues there, right? Well, with tasks, we need to actually use a function called finish execute, and that way it will actually finish the process and then start it all over again. So if we go back into the task here, we can add a finish execute node, and this will basically tell the behavior tree, hey, this task is complete. And this success Boolean is pretty important. So it will basically decide what to do next in a way. So if this is true, then when it hits the finish execute here, because we're using a sequence, it's going to move on to the next thing that's to the right. If we replace this with a selector, it's now going to reset back to the node that is above this. In this case, it's just going back to the root. But if you had another composite node like here, then it would go back up to the sequence. It's going to do whatever comes after this because this has now succeeded. So it's a lot of things kind of happening at once here. Basically, a selector won't run whatever is after this task unless this task fails. And then a sequence won't run whatever is after this task unless this task succeeds. Now, if we have this as false, then it's not going to run this because this has now failed. If this is a selector, though, it will run this. Okay, I'll just replace that with a sequence again. And so there's kind of a reason as for why it's called a success or fail. You can kind of think of it like if there's some kind of error with the task, like it couldn't complete, then that's a fail. And I'm actually going to rename this for now to move to random location. So when would move to random location fail? Well, it would fail if we were unsuccessful in getting our random reachable point, right? So in this case, we actually have a Boolean that will just determine that for us. So we can plug that into here. So this will actually not give good results because after it finishes, it's just going to go back and perform this operation like right away. The character will actually end up kind of turning instantly, like it's kind of a mess. So one way to fix that is by just using this and then performing the move to operation separately so that it's only going to complete, like it's only going to go back to the root again once we are done actually moving to the location. Now, of course, we could like check get actor location, like if that's equal to the goal here, constantly checking that. However, there is another way of doing it. I'm just going to get rid of that. And then I'm going to rename this back to get random location. So right now we want to store this information so that another task can use it. Now, normally what we would do is just promote this to a variable, and then we can drag this out and use it somewhere else in the blueprint. Now, this won't actually work right now because this variable can only be accessed by this task. And there's not really a good way of getting references to like specific tasks. However, we do have another way of storing this information, and this is using the Blackboard. So I'm just going to get rid of this variable, and I'm going to drag off from here, and then I'm going to search set Blackboard. So because I have context sensitivity on, it already shows set Blackboard value as vector. If I turn off context sensitivity, there's all these, basically these are actually the data types that a Blackboard can store. The only one that makes sense for this is vector. And then there's also this key. We can just promote that to a variable. And then we also need to click this to make it public. You can just name this random location key. Typically underscores are used instead of spaces. Blueprint doesn't really have a convention like that, is my understanding. So let's just connect this to there. We can compile, and then we can go back to the behavior tree. And now you actually see this thing here in the task. This has to do with the key. So you see this is actually the variable name that we set here. And the reason it has access to it is because it's public. So if I uncheck that, now it's no longer there. So let's do that again. Now we only see self actor here. These are actually the variables of our Blackboard. So I'm gonna go to the Blackboard here. Things are much simpler here. We can add a new key and we can add all of these data types. Let's add a vector and then just call it random location. So now we can use this as the key. It'll basically store this value inside this Blackboard variable. So now if we go move to, and then as the Blackboard key, we can set this to our random location from here, right? This will actually solve our problem. And then, yep. So you can see now the AI is just constantly finding a new random location to go to. They're going to there. Now you might be wondering why your AI isn't working, because I've had this problem in the past. Let's say you have your nav mesh bounds volume, you have your AI controller set up in here as the controller that you're using. One thing that might be happening is that auto activate in the character movement is off. So if I uncheck that, you can see the character isn't moving at all. They're just turning. So make sure that your character movement is activated. And auto possess AI should be set to placed in world by default. If it's disabled, then I don't think this is going to work. Yeah, it doesn't work. So make sure those two settings are also set. Let's summarize what we've done so far because it's a lot. First, we added all of our things that we needed to add to get started. We attached our character to the AI controller that we added. Then we told the AI controller to run our behavior tree. And we told the AI to generate a random location around it and move to that location. Let's see if we can start competing with Manny here. I'm just going to drag this and scale it to encompass the entire area. Let's have the AI start right there. And let's have player start. Oh, it's giving me a bad size error, huh? Oh, whatever. And the destination will be right here. Want to get to this cube. And let's also, we also need a trigger box. Add a trigger box. And let's just add a script. Let's put it in third person blueprints. And then when we have an overlap, we're going to check if it is our enemy or if it's our player or person character. Casting twice like this generally isn't great. It's better to use an interface. Just trying to get this set up here. If it's our enemy, we're gonna say that you lost. And then if it's our character, I'm gonna say you won. I think I'm just gonna get the character movement. And just deactivate it. So let's just and can I get character movement directly from here? I think I can, yeah. Deactivate. And this will just access the player, the third person character that we have in here. And let's connect that. And there are some other useful functions in the AI controller. I don't know if I'll need to use them here, but if we get AI controller, we can get brain component and stop logic. You might want to do this if your character is like dead. It'll basically just disable or stop running the behavior tree. So let's compile that, and then of course we need to have our enemy sort of start moving to the destination rather than just a random point. So let's go back into the behavior tree, and you know what? I'm actually going to rename this to destination now. And instead of random location, about destination key. And let's just do make vector, and let's set it to the location of this cube, which is roughly the center of the trigger box. Let's make the trigger box a little bit bigger just in case. And let's just copy this X, Y, and Z. And let's plug that in there. And I'm also going to tick this, compile. And then the acceptable radius is like if it's within 5 centimeters of the destination, then the process is going to complete successfully. I'll just set it to 20. I think we're all set up other than one issue here, which you'll actually see when we run it. And I'll leave that as something you can figure out. So you can see if the AI, yep, so it says you lost, I can no longer move. But yeah, the AI is able to move even after I have won. And I just encountered another issue. Sometimes, for whatever reason, if you have project goal location in the move to settings in the advanced, if you have that on, like it just won't work. Yeah. So if I go back into here, turn that off, save. Yeah, so now it's working. So now you should have a pretty good understanding of navigation with an AI character. There's a lot more to learn. That being said, it's kind of hard to find this kind of stuff. So I did find a pretty good course that I'll link in the description if you're interested in that. Kind of goes over a whole combat system. All right, thank you for watching.